Hello everyone. I've got some good news for you. There is no new material this week, and there will be no quiz and no reading assignment. This is to give you time during the week to prepare for and then take the midterm examination. The examination is open book and open notes. Bring all the materials you care to have with you. Knowing the building codes is as much about knowing how to find things as it is about your memory. The NYCBC will be the reference code for the examination, and it is the one we've been working with so far. Please be ready to go online to the NYCBC during the test if needed. You can practice by accessing the website at the link shown here. I do ask that you make it a point to be available for the Tuesday 7 p.m. live chat office hours. That hasn't been well attended, and it's a great chance to ask me questions before the examination. Here's my advice for taking the examination. The first step is believing in yourself. I know we are covering a lot of material, but as you have probably already figured out, Codes class is about learning and participation. Please do not be too stressed about the test or panic if you do not feel you know the answers. Just keep at it for the full time that's allowed. Complete the test and show your work as well as you can. To prepare, please print out the resources you'd like to use well in advance of the test. Gather your notes and perhaps print the PDF lecture notes or slides that are available for each module on Canvas. The handouts that will be needed for numerous exam questions will be available before the test as well. Please take the opportunity to download them, print them, and look them over. Also, if you are not comfortable going online to look up code information from the NYCBC during the test, you can print out either the slides from presentations that show code sections or tables, or print any code sections or tables that you think you will need directly from the online code. The ones that appear in the lecture materials are the most likely to be used on the test. Whatever you choose to do, please prepare your materials before the test period starts to save time for work on the actual questions of the examination. Here is an important request. Bring some scratch paper. Maybe several sheets of scratch paper. If you use them or if you draw on other materials, please scan or photograph them and send them as a Canvas email attachment. I may be able to give you some partial credit if you use the scratch paper and send it in. Finally, please set aside 2 hours with no distractions and no phones. This means turning off your phone and logging out of online messaging services. This examination will cover the major topics that we have covered so far in the class, the things that I've spent time discussing in my lectures. It will also test your ability to locate things in the building codes. Finally, please note that Project 1 was really good practice for taking the test. It involved using a floor plan and some bits of information, together with your knowledge of the building code, to find missing pieces. The part I've always found to be the most fun about understanding the building codes and using them is that it's kind of like detective work. A lot of this examination is about knowing where to find things and then tracking them down. Here are the points that I would like you to focus on when you are studying for the examination. The difference between prescriptive and performance-based design, important organizations and documents. These will all show up in the lectures. The code and approvals processed we analyzed in Assignment 2 for Module 2. Key definitions, the ones I consider most important, should be easily found on the lecture slides. Occupancy classifications and construction type, including performing maximum height and area calculations. The active systems and passive systems for safety. Using compartmentation, meaning fire resistance rated walls and fire protection rated doors. Special features and components of a building. These are all those extra classifications that are not construction type nor occupancy classification. Egress and using it for building organization. Definitely know the 3 types of limited travel distances and know how to figure out how many exits are required from a space or story. All the information in Project 1 is useful. And finally, in Assignment 2 for Module 6, you learned a lot about means of egress and occupant load. Those are also key topics. Today's lecture is about preparing you for the test. From the list of information that will be on the test on the previous image, we know that information from the homework will include it. As a result, we will look at 3 of our past assignments during this lecture as well. Having diligently completed the weekly assignments and quizzes will put you in a position to do well on the exam. We've discussed 2 approaches to building safety for designers to use. Mostly we have talked about prescriptive compliance, but we have also talked about performance-based design. Unlike complying with stated code requirements as is done in a prescriptive compliance approach, using performance-based design requires the design team to determine safety goals and objectives, work with the authority having jurisdiction to turn these into criteria, and then develop a design that achieves the objectives. Notice that in both approaches shown here, the designer and the team has to follow the approvals process in the jurisdiction. Both also include significant amounts of documentation. The flowchart shown here is an example of how fire engineers and authorities having jurisdiction prefer for a performance-based design process to work. This approach, starting from the top and going down to the bottom, is reasonably standard and comes from a design guide addressing just this issue. On the right-hand side, you will see the key document, the Fire Protection Engineering Design Brief. Receiving approvals from the authority having jurisdiction is just one part of the overall code and approvals process that we have studied in a previous assignment. Here are the correct answers from that assignment. In the assignment, we attempted to connect specific activities to their relative locations and to their location in the greater design and construction process. The chart at the bottom shows the entire process of design, construction, and finally occupying the building. The beginning of the code and approvals process, which is called the design process here, is shown. Note that some review of the prescriptive requirements is necessary before approaching the authority having jurisdiction with any performance-based design ideas, and that both review and performance-based proposals precede actually starting the design and the layout of a space or a building. Construction documents are likely the most important deliverable that an interior designer will contribute towards the construction process. The second stage, called the permit process, is when the authority having jurisdiction reviews the design, provides feedback, and finally allows construction to begin. This occurs after the design has concluded but before construction starts. The keys to this part of the process are proper documentation, following the authorities having jurisdiction's instruction, and remembering that the design team is responsible for safety in a design, not the approving authority. During the construction process, the final stage of the code and approvals process, the designer is likely to interact with contractors. Contractors and subcontractors are the people and firms who do the work of making the physical building. They are especially important with respect to design-build active fire safety systems, like fire alarm and sprinkler. Finally, both the construction process and the code and approvals process will conclude with issuing a certificate of occupancy. Many of the important definitions we've covered are provided in the lectures and have been shown like this with their own special font. You could also look at the glossary of the textbook as part of your test preparation to remind yourself of the new terms you have encountered during this class. During the lectures, we have also identified important organizations and the different codes and standards. These have names and frequently also have abbreviations that I hope you have picked up on through repetition. Knowing this shorthand is part of being a design professional. Something that you've probably figured out during our module covering egress is that numerous requirements are based on the occupancy classifications of a space. You can't apply these requirements effectively if you're not able to determine the occupancy of a space based on its use. As a result, it is necessary to get comfortable with Chapter 3 of the NYCBC and the different letter occupancy classifications used in this code and other IBC-based codes. Please remember that many of the occupancy classifications have multiple numbered subclassifications, like for example A2. These also affect their requirements. Passive and active safety systems were each the focus of their own lectures, and as a result, you know they are important to study. Compartmentation and fire resistance ratings are good examples of passive systems. On the other hand, active systems include all the electrical and water-related fire safety systems. Additional systems within buildings, such as exit signs and emergency lighting, relate most directly to the means of egress that they serve. For me, the number one rule of passive systems is that we use compartmentation to prevent the spread of fire and smoke from one floor to another. During our study of passive systems, we learned about the importance of fire resistance rated assemblies for construction type and compartmentation, as well as the fire protection rated assemblies for opening protectives. An assembly is all the pieces working together and listed for that use. By now, everyone should know about the different types of buildings addressed in the code, especially high-rises and buildings with atrium. The same is true of the different types of existing projects like repairs, alterations, additions, and change of occupancy. Please know when your project includes these and know their precise and very measurable definitions. The codes are very good at providing precise definitions. We have studied how to use egress requirements and the progression of increasing safety to organize a building or a floor plan. As interior designers, you will often work in tenant fit-outs and existing buildings. These are spaces where the main egress strategy is likely already in place, but this does not make it any less important for you to understand how egress works. We learned to calculate occupant load and had opportunities to practice it in both Project 1 and the homework assignment from the Means of Egress module. Another part of our discussion of egress was combining egress with passive strategies, specifically compartmentation, as in the case of an exit stairway enclosure. I hope everyone enjoyed the lecture on egress. As I've said before, it is one of my favorite things to work on, and I hope as a teacher I can be useful for you on this subject. Now let's look at the egress assignment together. Here is the floor plan and the table of room areas from the proposed design in that assignment. The first thing I'd like to point out is the tidy separation of gross and net occupant load factors in this floor plan. The hotel component, shown in red, is a gross residential occupant load of 1 person per 200 square feet. Notice how all areas are included. In the assembly space area, a variety of net occupant load factors have been applied to individual spaces, and these have been shown in blue. Notice how circulation and core spaces in an area using net occupant load factors do not need an occupant load. While pre-function areas may contain occupants at certain times, these occupants are on their way in and their way out of the assembly spaces served by the pre-function space. In most cases, assigning an occupant load to the programmed space only is sufficient. We can use the term non-simultaneous use to describe the way pre-function spaces, circulation spaces, and restrooms work in areas where net occupant load factors have been applied. The people are either in one space or the other, so we only need to count them one time. We can take the areas provided and determine occupant loads for all of the spaces on this table. The nice thing about the occupant load for the hotel component is that because it is a predictable and normal sort of space, with one specific use, we are allowed to apply a single gross area occupant load factor from the building code. As a result, it is one quick calculation for that whole area. The assembly rooms, based on the description in the assignment, should all be assigned an occupant load based on 15 net square feet per person. The occupant loads assigned to these two spaces and their respective occupancy classifications of Group R1 for the hotel and Group A3 for the assembly area are the starting point for taking a critical look at means of egress in this design. Remember that occupancy classification informs the key requirements for maximum travel distances and the minimum required number of exits. The first thing that should jump out at us in this floor plan is that there are 2 exit stairways provided from the assembly area, but that space has more than 500 occupants, so a 3rd exit from this area of the story is needed. For your reference, here are the maximum travel distances associated with these 2 occupancy groups. Maximum lengths for exit access travel distance, common path of travel, and dead-end corridors will need to be checked on this floor plan. I highly recommend making a table like this when you are doing your code research and starting out on a design. The assignment asked you to identify the problems with egress compliance in this design. Here are the locations of the answers for the assignment, and this presents us with a good chance to review them and go through important egress concepts from the lecture and the reading. As I previously indicated, a 3rd means of egress is necessary. In the role of interior designer, it would be difficult to add a stairway without input from the architect and engineer, so perhaps we can provide a route to the nearest available stairway on this level that is not currently accessed from our assembly area. Unfortunately, the kitchen is currently in the way of this means of egress, and because it is more hazardous than adjacent areas, it is not appropriate to have a kitchen as an intervening room. Hopefully you also found that there are some dead-end corridors that are in excess of the maximum allowable length for this condition. Remember that the dead-end corridor limitation is about limiting the distance a person can travel in error on a path that does not take them towards an exit. The maximum allowable length for dead-end corridors is based on occupancy classification. Zooming in for a moment on the residential component, there are instances of common path of travel that exceed the maximum allowable length for this dimension. Common path of travel is usually the measurement of travel towards an exit, but before an occupant is able to choose between two different exit options. Often this will happen in the same area of a floor plan as a dead-end corridor, but the two are not necessarily related. Common path of travel can be more challenging to correct. Numerous rooms in the assembly space have an occupant load of 75 or more people, and as a result, a second remote means of egress is required from each of these spaces. Currently, there are spaces in the design where this is not provided. As a note of caution, the NYCBC applies a maximum of 74 persons before an assembly space needs a second means of egress. In many other jurisdictions and in the model code, this maximum number is 49 persons. The event garden is shown as an exterior terrace. Exterior spaces on the above grade levels of a building also require egress back into the building and towards stairways in the same way an interior room would. These exits should probably be located to provide direct access to the building interior through the pre-function space in order to prevent the complexity of exiting through adjacent rooms. This was not shown on the proposed design. Here is a very important egress concept. This space requires two means of egress, and two are provided. However, they are not separated by the minimum distance in comparison to the maximum diagonal distance of the space. It also doesn't necessarily lead towards an exit as shown in the proposed design. As a result, even though two doors are provided out of the room, the two required means of egress requirement is not met. One final error from the proposed design, and this one was a bit challenging to find. Please note that when partitions are provided within a space, each of the partitioned spaces needs to comply with egress requirements. In this case, two remote means of egress are required based on the occupant load of these spaces when the partitions are in place. This makes sense if you think about it, because people cannot go through the partitions. Some movable partitions can have exits through them, others cannot. Additional exit routes are required because the occupant load exceeds the allowable maximum in the NYCBC, specifically Table 1015.1. The addition of the following egress routes would correct these egress issues and are probably possible in the context of this design. Remember that the kitchen wall locations also will have to change so that circulation and egress do not pass directly through the kitchen if we are intending to use a route north as one of our ways to exit the assembly space. Please take another moment to consider all the things we looked at in the process of doing this assignment. The assignment involved calculating occupant load using Table 1004.2 from the NYCBC and got us thinking about using means of egress to organize the floor plan of a building. Now we can move on to Project 1. This was an opportunity to look at numerous different ideas from several different lectures and apply them to a single design situation. This project was harder than anything you will find on the examination, and I wanted to give you an opportunity to try to work through multiple steps in the compliance process and maybe use the internet or reference documents to track down some answers. You'll remember that Project 1 started with this existing story from an existing office building. The floor plan includes key information about conditions that will not change, but also the floor plan design that is proposed to go away as this part of this project. The story is being converted to a conference center that can be rented out independently of the stories around it. Your design firm has done a preliminary layout that is shown here. Notice the things that don't move when you do a tenant fit-out. Elevators, exit stairway enclosures, and restrooms are difficult and usually expensive to change. So normally they don't change most of the time, and this project is no exception. In Project 1, I asked you to provide as much information as possible in terms of codes compliance. A truly complete answer to this request would have started out with recognition that this is no longer a Group B office occupancy. Look at all those large seating areas and open spaces that can be used for gathering people. This is an assembly occupancy area. Neither the adjacent floors, which are separate tenant spaces, nor what the project used to be used for are going to matter in terms of the new design. We are also changing the configuration of the space but not adding more floor area. This means the code defines the project as an alteration. Occupancy group has also changed, and I apologize for being a bit sneaky with this, but did anyone think to do a maximum allowable height and area calculation as part of their review of the design? The instructions gave you the information needed to determine this, and it is a pretty standard step in any change of occupancy project, but it may not seem like the most obvious thing to do because it doesn't involve going straight into floor plan analysis. To use a new occupancy group in a building, the construction type, presence of sprinklers, and other features need to allow for that occupancy to be on the floor where the new design is proposed. If it wouldn't be safe and allowable to put this proposed occupancy on such a high floor in new construction, in this case the 7th floor, then it is not permissible to do so in an existing building. With that in mind, let's take a look at the occupancy calculation that would be involved here before we go on to the fun part of looking at the floor plan in Project 1. The information provided in the Project 1 assignment gave us the minimum as-built fire resistance ratings for the structural elements of the existing building. Remember that to define the construction type, it is necessary to check all the structural elements and that they meet the minimum fire resistance for their respective element for the construction type shown in Table 601. In this case, the building turns out to be construction type 2A. This is an existing condition and a condition that will continue with the new design. We know our construction type of 2A and our occupancy group of A3, and this allows us to use Table 503. First, we locate the tabular values for maximum height in feet, maximum height in stories, and maximum area per story associated with the combination of the existing construction type and the new occupancy classification. In this case, the table would allow the building to be 65 feet tall, have 6 above-grade stories, and have a maximum area per story of 17,500 feet. We know these figures are going to increase, though. Now we apply the increases allowed in sections 504 and 506 of the NYCBC. An additional story is allowed due to the presence of sprinklers. This is what makes having an assembly occupancy on the 7th story of the project as described permissible per the code. If the proposed location of this project was 1 story higher in the building, the whole project would not be compliant. The maximum allowable area per story for group A3 must also be met by the proposed use. The allowable area per story will increase from this tabular value due to the presence of sprinklers and frontage. Our building floor plan is relatively small, so this does not affect the assignment, but please review the previous lecture materials on these increases in area and get comfortable with the location of the code section describing these increases. Moving on to the floor plan. Let's look at occupant load for the proposed design. If you did this in less detail when completing your assignment, that is totally fine. After all, the description in the assignment of this design is that it is an initial proposal, rather than a fully developed approach coming from the design team. First, we divide the story up into areas of similar use with special attention to the large rooms to make sure that they have enough exits for the occupant loads present within them. Everyone looks at buildings a bit differently, but these are the areas I would pick and their respective measurements. You didn't have to get this detailed on the measurements. A bit of rounding is fine. The big conference rooms are clearly important spaces. Notice that one of them can be divided into 4 parts by partitions, so if we had wanted to do the occupant load for each one of those 4 partitioned areas separately, we could also have done that. Then there is the big waiting room or breakout or lounge type space on the north side of the project, all 3,700 plus square feet of it. It would be a good idea to get feedback from the authority having jurisdiction about this space, because this use doesn't appear to neatly fit into any of the classifications offered in NYCBC Table 1004.1.1. Because I see this primarily as a pre-function space for the conference center, I would not feel obligated to put a dense assembly use occupant load in this space. However, the code official or fire marshal may disagree. An occupant load factor in between 15 square feet per person and 100 square feet per person is appropriate for that area, and either is correct in your assignment as long as you have some justification for why you are applying it. We also have a few less densely occupied office use spaces in the program. These are pretty clearly for the staff. See that area just east of the conference room? Someone clearly works at that desk. There are also some less densely occupied storage and mechanical rooms present in the floor plan. Here is the application of the occupant load factors to these areas as I would have done it. Note that we have lots of 15 square feet per person and lots of 100 square feet per person. And here are those same occupant loads shown in context. This type of information is often shown on a life safety or code compliance floor plan or diagram in the set of design drawings. Notice that the remaining corridors, not shown in any of the area, could have been treated as either one person per 100 square feet or as a non-simultaneous use space and not loaded as I've shown here. Either is a good answer in your assignment, and in the actual project, it could depend on the preference of the authority having jurisdiction. Now let's look at the layout criteria for manual fire alarms and portable fire extinguishers. You can find requirements for these devices in the building code, and in some jurisdictions, layout criteria for these devices will be found in either the building code or the fire code. The NYCBC references the requirements from NFPA 72, a reference standard, for the alarms, and NFPA 10, another reference standard, for the extinguishers. This is a common approach for building codes, and I wanted you to see it in action. Manual alarms are an active fire safety system and part of the fire alarm system. The building may not require these under the current code, but if the owner and fire alarm system designer decide to include them, and they frequently will, then the spacing must meet specific requirements. The spacing criteria, as discussed previously in this class, are to provide alarms within 5 feet of the exit doors and to distribute alarms on the floor plan so that no area is more than 200 feet of travel distance from an alarm. Portable fire extinguishers are required at specifically hazardous places within the building, such as kitchens and rooms with hazardous materials or equipment. They are also required to be laid out so that A, no space is more than 75 feet from an extinguisher, and B, an appropriate quantity of extinguishing capability is provided based on the hazard classification of the space. This idea of quantity is provided in the table at the bottom left. A typical extinguisher is normally sized 4A for the purposes of this table, as in the label on the extinguisher calling it out as 4ABC. And in this case, our space is a light hazard occupancy. Don't worry too much about this for the examination, but I hope you tried to figure it out as part of the assignment. Manual fire alarms can be located near the exit on whichever wall is available. Just make sure not to locate them behind a door because the door will have to open. As it turns out, no location on the floor plan is more than 200 feet from one of the two locations shown here, so arranging these systems is pretty simple. 2 of them is enough. Fire extinguishers are going to be driven by the presence of 2 little kitchenette spaces on the floor plan. See them at the bottom left and one of the extinguishers on the right. Both of these should have a fire extinguisher since people might set up a toaster or hot plate or some other cooking tool that creates a fire risk. Also, we see that 75 feet of distance is not nearly as far as the 200 feet of distance on the previous slide. So we're going to need to find useful locations for extinguishers that are on walls that are visible but not on the nicely finished walls or located such they would impede doors. There are lots of potential right answers here, and I came to the conclusion that about 5 extinguishers are needed. Note that when it comes to area coverage per the little chart, if we have as many extinguishers times 4A for each, we would end up with 20 units of A, and that is certainly enough extinguishing capability to cover this area. So you could get a layout to answer the assignment on this floor plan without going into detail with that specific criteria. Note that one of the kitchen extinguishers is inside an enclosed kitchen and can't be seen from the adjacent corridor. As a result, we should not count that extinguisher towards the extinguishers that are within 75 feet of the building spaces, since the occupants can't see them and use them. Fire resistance rated walls are shown here. Basically, we have 3 types of walls present on this story. Walls related to separating shafts from the area on this level, which are 2-hour rated. Walls that separate areas of refuge from the story, which are also 2 hours, as well as walls that separate incidental uses and major mechanical rooms, which are 1 hour. The point I think this drawing shows is that in a sprinklered assembly occupancy, the corridors do not require a rating, and neither do most walls. This is representative of a lot of interior alteration or tenant fit-out projects, because often the fire resistance rated walls are the ones that the interior designer does not change. That said, it is important to be able to identify wall rating requirements from the context clues so you know they are present. Before we say goodbye to Project 1, here is one more look at the tasks we practiced during this assignment. I'm hoping to catch up with as many of you as possible during office hours this week. Please attend and bring your questions. Finally, please look at your schedule and make time to study for and then take your midterm examination. It is essential to get the examination handouts printed before you go online to take the exam because a number of questions will be based on them. Good luck with your studies and the examination.